Welcome to the Brain Pal podcast. We're on a mission to improve the world through neuroscience. This is your host, Devin Rowe, and today I'm meeting with Jurriaan Schreuder. Jurriaan is a PhD student in brain and cognition at University of Amsterdam, where he is also completing a postdoc in cellular biology and computational neuroscience. Quite the combination, huh? He also runs Kexu, a tech company focused on applied computer vision. They have a wearable eye tracker called OpenEye, which can be used to measure where people's attention, visually, is going. I was very excited to speak with Jurriaan because in many ways he's a bit of a renaissance man. Not only does he have a very deep knowledge of neuroscience and cognitive science, but he's also applying that knowledge to the real world and creating success for himself in doing so. And those are often the people I want to speak with the most. People applying neuroscience to real life. Because one of the missions of this podcast is to create more good publicity for neuroscience and also both show and tell people how they can apply neuroscience to real life. Now, with that said, let's start the show. All right, Jurriaan, I'm really excited for this. So to start, let's start with a brief background of your early life. Were you always interested in the brain and understanding how people work and behavior and stuff like that?
Well, actually, when I was in high school, I wanted to study artificial intelligence. And then I read but that was really a long time ago. There was almost no artificial intelligence yet. And then I read in a newspaper that the university study of artificial intelligence, only 10% of the people got their exam. So I thought, no, I'm not going to take that risk. I'm not such a good student. So I'm just going to... so I thought, okay, what is the study artificial intelligence? It's a little bit psychology and it's a little bit learning how to program. And I thought, okay, programming I already kind of know and I can kind of teach it myself. And
Yes.
Psychology is kind of an easier university degree. And then I'm sure, like, even with my attitude at that time as a teenager, that I was going to complete the study.
Yes.
So then I studied psychology and I started working 2 days a week as a software developer, first making Android and iOS apps, and Unity, and then more backend, and then slowly more advanced.
Here's a question, sorry to interrupt. So you say you weren't a good student, but you've gone on to get your PhD and your postdoc. So did you become a better student as you matured, or what?
Actually, yeah, there was a dip when I was around 16. When I was 12 to 15, I was a really good student. Then when I hit puberty, I was a really bad student. I thought, oh, I'm just gonna pick an easy study, and then later in the university, I was really one of the highest in my class. I've got I think maybe the highest grade for my thesis out of about 500 students. So the first year of my university, I wasn't so motivated, but
Yes.
afterwards I got back into like all the weird, crazy partying as a teenager went away, and I became interested in boring school stuff and brain stuff and that kind of stuff. Yeah.
I see. So then one more question on that. Well, two. So you started undergrad, or the Dutch equivalent undergrad, at about age 18, is that correct?
Yeah, 19. Yeah.
I see. Okay, so as an adult. And then what would you say changed? Do you think it was just the hormones or something changed and you were able to get yourself under control, or did you have some experiences that made you say, hey, I should really start focusing more
Yeah,
on
I think
school?
so. Now I'm not scared anymore to be a nerd and to read books. But when I was 16, I was like, no, it's not cool to have your backpack to school.
Yeah.
So I never took my books to school, and I always had a big mouth against teachers, and I always got in trouble, and I was always expelled. And then later I was. Right now, I have a problem that I buy too many books, and more that kind of problem.
I see. So would you say it might have had something, I don't want to spend too much time on this, but now I'm really interested. Would you say this had something to do with like your peers or the people around you? Like in do they call it gymnasium, like in German, in Dutch? What do they call that high school in the Netherlands?
Yeah, it was just, at that time I wanted to be cool, and school was not cool. So being bad at school and not doing your homework was cool, and not knowing when the tests were was cool. And
Yeah.
then when I got a little bit older, was knowing a lot about stuff was cool, and being one of the smarter people, and
I see.
being ambitious, and having a good job, and that kind of stuff becomes more important later.
I see. And then going back to your development jobs, can you go on about that?
My story, man.
Your development jobs, you said you were doing some Android development, right?
Oh yeah, my development. Yeah. So yeah, I made Android apps when Android first came out, and that was really a time when you could create a fart pillow app and then get 1 million downloads, and they would pay 80 cents for that. So I was a little bit later than that, but I had in total more than 1 million downloads. I was making 1,800 euros a month for my own apps.
Wow.
And the app that made the most money, I actually made that in 4 hours. So
Really?
that was really nice time to be an app developer. And then someone heard that I could make apps, and then they hired me at a software company. And then I could get a little bit experience in software development.
So around when was this when you were creating these apps? This sounds like had to be like 2008, 2009, 2010, or?
Yeah, I made apps for the first Samsung. It was a Samsung S.
Really?
Without a number.
You don't look that old.
No, I'm 38 years old.
Really? Well, I didn't even think you were that old. I thought you had to be like your early 30s.
No, I'm really old.
Well, you're doing something right. Okay, so that's interesting. So, you, in your youth, or I guess as you were deciding on your college major, you had some interest in AI, and then you decided that psychology might be a good route, and then you got into this development. Did you always have some interest in like business and entrepreneurship?
Yeah. So basically, all my life, I wanted to have my own company, and I wanted to do artificial intelligence. So it's, I think that makes it easier, I guess, if you just stay on the same path for a really long time.
Yes.
Because if you change direction all the time, then it's every time you have to start again from scratch. And yeah, for me it was like I always wanted to do that. I was always very interested in it. And then at the university I did at the university psychology. I did connectionism, and that subject was really my favorite subject. Then I learned about neurons and creating artificial neurons. And in that subject, they showed me how a hope field network could solve the Queen's problem. For anyone who doesn't know what the Queen's problem is putting as many queens on a chessboard without them being able to take each other. So any path the queen can take is a path another queen cannot take.
Yes.
So actually, what you do is make all the other squares, you make them neurons, and you make the connection to them inhibitory. So then in a hope field network, they say like, okay, that place is a bad place to put another queen. And I thought, hey, in that same way, you could solve a Sudoku puzzle. So then the next lesson, actually, I got to the teacher and said, hey, remember you told me about the Queen's problem? I made a hope field network that can solve Sudoku puzzles. And after that, he said, you are the best student that I ever had in my whole career as a neural network teacher.
I see.
So then we really
change.
became friends. And too bad the Sudoku solver is not online anymore because it was made in Flash, an ActionScript.
Well.
And
that's not even that old. You don't look that
yeah. And since 2 years it stopped working.
Yeah.
So now I have to create a new one in JavaScript. So I still because it's still used in the same class to explain what a hope field network is. So I still use it. And now actually I teach one of the classes in that subject. So so that's really one of my favorite things is building neural networks and kind of simulating the brain and building that kind of stuff.
I see. Okay. And then before we move on to your education a little bit more, did you always have like some interests? Or what I'm getting at is like, what was it that got you interested in entrepreneurship? Do you think it was natural, or did you have were your parents entrepreneurs, or were there entrepreneurs you knew and you were like, wow, I want to do that?
Yeah, of course, it was also a little bit because I was making apps. So then I was always making a little bit of money with my own company. So
Yes.
you have to have some kind of legal entity to get paid from that app. So I basically already had a company from a very young age. But I also sold T-shirts and I always kind of had small kind of business ideas and things next to my education. So I always really liked that.
I see. So it's kind of like you had been doing it so much that you really understood that you liked it and you wanted to keep doing it.
Yeah, I guess so. Yeah. But I was always talking about it. I was always talking about, I'm going to start my own company. And then everyone was saying like, yeah, one day he's really going to be a millionaire because he's always talking about starting his own company.
I see.
So then after a while, I just got kind of swooped up at this IT company. So I was just working there as a software developer and slowly more as kind of an artificial intelligence developer. But and then after a while, really, I kind of got more customers and people were asking me like, can you build this for me? Can you build this for me? And they were paying way more than the company was paying me. So I said, bye guys, I'm starting my own company.
Yes.
And then slowly I got more assignments, more clients, and then building more and more stuff.
I see. Very impressive. Because it's pretty rare to see, I think, with people that, at least in my experience, it's pretty rare to see with people who are in like the psychology and the neuroscience and brain sciences. I was like one of the only people who was interested in business in my class. Everybody wanted to be either a doctor or a psychologist or a psychiatrist, or they were just studying it because they didn't know what else to study. So it's pretty rare, I think, to both have that interest and keep pursuing it.
That's not in my faculty. So there, I think half the professors there have their own company next to the.
Really?
Next to the yeah. So everyone has their own company there. Yeah.
That's interesting.
It's very entrepreneurial minded.
Yeah, it sounds like it. Okay, so while we're on the topic of the your academic environment, so you did your undergrad. What made you want to go on and do your master's and PhD? Was there something you really liked about the program? Because it sounds like you have probably gotten a lot out of that program.
Yeah, first I did my bachelor's in brain and cognition. And then I did the research master in brain and cognition. And actually you need kind of to have high grades for it. And you need to be, there's 500 people each year doing psychology. And maybe 30 or 50 people each year being allowed into the research master.
I see. Let me ask you another question about that.
Yeah.
This maybe sounds like something that would be unfamiliar to a lot of people. So it sounds like you did a master's, and then there's a separate research master's. Is that correct?
No, the normal master's is 1 year, and the research master's is more difficult and is 2 years.
I see. Now, is that a program you did after the master's?
No. It's instead of the master's.
Okay,
so it's like a master's for the smart kids.
I see. Yeah, of course.
And I really liked that way more because I was always already doing subjects from the research masters because subjects were just way nicer. It was more complex and more interesting for me. So it was really a natural choice for me to do that.
I see. So it sounds like it was based on what was happening, it sounds like it was a relatively easy, simple decision for you to say, okay, let's keep going.
Yeah. Yeah, and then my PhD, I did my PhD next to working as a software developer. So I only did it 2 days a week. And so I was already working, but it was a little bit much because I was always working, and then I was doing my PhD, and then I was interested in starting my own company, so I was always doing a lot of side projects.
I see.
So it got a little bit more relaxed when I started making enough money with my side projects that I could kind of just focus on research and company.
I see. Yeah, we'll have to talk about, if time permits, we'll have to talk about your time management systems because that sounds like a lot to be doing.
Yeah.
Okay, so
Yeah,
then after
my
your PhD, are you currently in the postdoc, or are you have you finished the postdoc?
well, I'm actually kind of in between. Like, I still need to finish the last bits of my PhD, and I already started with postdoc. Well, you can't really call it a postdoc because I still need the official diploma.
I see.
But now with time management, it is a little bit because I used to have like certain days for the university, and now those days I'm already doing my postdoc. And now in the weekend and the evenings, I have to finish my PhD. So it is a little bit. I will be really happy when I finish my PhD and get my weekends back. So that's for time management. Yeah, it is. It is. It's easier just to do one thing.
Of course.
If you want to,
Yeah, it's hard to do
want to
one
do
thing.
time management good, you don't do what I do.
Yeah, of course. Yeah, I mean, it's hard to do
Little
one
bit
thing.
too much.
Well, if you're doing three things, that's certainly
Yeah, but
increasing the complexity.
I do think it's. I always think that I'm really glad that that when I just started, that I always kind of did work and university and my own projects at the same time, because I kind of always did it. Because I worked 2 days next to the university, and in the university I always had also my own startups.
Yes.
So I kind of always kind of did that, and I think because I did so many things at the same time all the time, it was really difficult, and it was really difficult to do it. But it also taught me how to do it a little bit, so I did get used to it. And then when you have your own company, you always have like a lot of clients at the same time, a lot of projects at the same time, and you're always like, you don't have to do all of them yourself, but you all have to have them all in your head at the same time, kind of all the different deadlines of all the different projects. So I think it did help me to kind of not pick the easy path, but pick a little bit more difficult path and kind of learn some skills along the way.
I see. Yeah, it's good to hear that because you are 12 years older than me. And one thing I've always thought about, I think from a young age is, well, if I can pick between doing the easy thing and the hard thing that may or may not work, I think if you keep doing the hard things, eventually you're going to get a skill for doing harder things. So then those hard things become easier. But if you just do the easy thing, then you'll do the easy thing, but you'll never get good at doing the hard things.
Yeah, it's also if it's also doing things that you're passionate about.
Yes.
Because some things, they may not be super useful, but you're really passionate about them. And that makes you put in a lot more effort. And so then you will progress a lot faster because you just have so much more energy to do that thing. And then maybe it's not that useful right away, but you need a lot of skills to... One of the examples, I think, is quantum computers. There's so much money thrown into developing quantum computers, and are they actually that useful? And there's almost no progress. But I think that so many people are so like magically attracted to the idea of quantum computers, and they're willing to invest so much time and energy in it. And there's so many kind of other techniques that you need to develop. You need to develop all kind of new tools and all kind of new systems and stuff. So I think so much technology, kind of not even that related to quantum computers, will come out of those very passionate people. That just spend so much time into solving that maybe a little bit useless problem. But there's just so much obstacles they overcome along the way.
Oh yeah, I think we're probably seeing something similar when it comes to AI and machine learning, because I think there was kind of like what at least felt like a dark age up until relatively recently, when we've been talking about AI and machine learning for decades, since like the 60s. We haven't seen that much when it comes to utility until, I'd say, relatively recently. But now we've got things like ChatGPT and these programs that can write copy for you or make images for you. It's kind of like there was an explosion, so to speak, in utility, but that only came because there were people who were working so hard and so passionately on it, even in the face of not knowing what was ahead of them, so to speak.
Yeah,
I
yeah.
think makes sense.
And probably also, I think a lot of it is also funded because to enable self-driving cars.
Yes.
Because a lot of those AI companies are really financed to get self-driving cars, and we know like once we have self-driving cars, every car company will want it. It's going to be $1 billion dollar industry.
Yes.
So I think a lot of those techniques are just developed also for maybe to sell them to self-driving cars.
Yes, of course. Now, on the postdoc program, when I was looking at your LinkedIn, it looks like it's in computational biology. Is that right?
Yeah, cellular biology and computational neuroscience.
I see. I see.
But
So,
I do mostly the computational neuroscience part. So I build the network, but I work in a team that also slices open rats. It's not really my favorite thing to do.
yeah.
But so I'm not really the cellular biology mostly part of that team.
Mhm.
But I'm really interested in cellular biology because if you want to create the brain, you have to first see how it works in the. So I always think that computational biology, computational neuroscience is building an interactive map of the brain.
Yes.
So you can say like, oh, this is how the brain works. This is how it learns. This is how it, and it's all. There's a lot of theories how the brain learns, how the brain does this, but then Richard Feynman he always said you only understand something if you can build it, and a lot of those things that they say this is how the brain works, if you put them in neurons in a computer, it actually does nothing.
Yes.
So then if you say like, okay, we investigate everything how all the neurons work, and now we know really everything about it, and we build it in the computer. And it also works just like the actual brain. So that's the final proof that you found the way that it works, and you're not just like building a theory that you can never prove.
Yeah.
So so to build those networks, you really have to study the neurons and the connectivity between the neurons and all the chemistry and all the ion channels and everything, how the cells work and grow. So a lot of times I'm just reading about how neurons work and how they grow and how cells work. So a big part of recreating the brain is studying cells.
I see. See, this sounds pretty ambitious.
Yeah.
So it sounds
It's a lot of studying how neurons work is also kind of hobby interest and how cells work, but you don't need every little detail for it to work. Actually, it's also dependent on what scale you build the brain. So if you want to build a model of 20 neurons, you will want to have every detail of those neurons correct.
Yes.
But we're usually building neural networks with at least a couple of thousand neurons. And then you're not focusing that much on the details. You're more focusing on learning algorithms and on different types of spiking neurons. So then we kind of look into what brain areas have which type of neurons with which type of spiking properties, and then we try to get the same amount of this type of neuron, that type of neuron, and kind of get the exact same mix that you find in the brain and try to wire them in the same proportions that you find in the brain. So that's kind of how we slowly try to recreate the brain as close as we can. But you always have to pick a certain zoom level. For instance, ChatGPT, it is a huge network.
Yes.
And you could say, that's the biggest neural network that we built, really close to how the brain works. But the neurons in that network are so oversimplified that you might, are they still neurons? They're basically a dot matrix multiplication. And that's about how close we still are to neurons. So it is. They also have connections at weights, but it's more they're looking more into how can we still keep kind of the concept of neurons, but make them as close to how GPUs work instead of how close to how the brain works. You can make a huge network, but then you have to really build it so the GPU is happy about it. And
if you're listening, you might want to be taking notes. I want to take some notes right now, but go on.
Oh yeah.
Just for the listeners, you might want to take some notes. So go on. So we were talking about from the GPUs.
Yeah. So now I'm building 2 neural networks, and one is a spiking neural network. So then actually we have 1,000 iterations per second. Mm-hmm. And so we have one time step every millisecond. And if you want to show the network, for instance, one image, you will show it for 1 second, and then you have 1,000 time steps. Then another network, we simplify the neurons a little bit more. We say, well, they don't have spikes, they don't have more or fewer spikes, but they have just one value. So then you don't need to show the image for 1,000 iterations. You just show it once, calculate the network. So the spiking neural network is 1,000 times heavier for the computer to simulate than the a little bit more simplified version of the brain that's still kind of realistic. But for the spiking neural network, we are, for instance, very interested in different brain waves that we simulate, like theta waves. We're simulating theta waves mainly, and you cannot simulate them if you don't have spiking neurons. So for some things, if you want to simulate them, you have to have spiking neural networks.
Yes.
But but if you just say, okay, we just take the average of spikes in 100 milliseconds and we just give it a value, then it's a way easier to calculate for the computer. So then you can create 1,000 times more neurons on the same computer hardware. And then, for instance, in the network I'm simulating, the connections, they can move, they can detach, attach, and they can move around. And that's kind of how we learn in the brain, is the connections constantly, the axons constantly attach and they detach and they try to find a better spot. And then after a while, that kind of so that's how the network learns, is that the axons go into different places and form connections there with a synapse with a certain weight. And for instance, for networks like ChatGPT, they don't have axons that can move. They just have things connected in a kind of small world type of way. So if you let the axons move for a long time, they will organize in a certain way to don't be too long. And then you have kind of, so in ChatGPT, they just say like, okay, we're just going to hard code that architecture, and we're going to also make them an exact kind of matrices that is lightest for the GPU to calculate. And then we're not going to move the axons, just these things are connected. And then we only change the weights of the synapses. So that's already like a little bit simplification.
Yes.
And then, for instance, in the brain, if you have a learning rule, and in the brain, the neurons don't know the values of the other neurons. So if the neuron wants to learn, it only knows about itself, so it can only use local information.
Yes.
But you can train a network way faster, more efficiently, if you just have it in a computer and, well, you know the value of every neuron, you know the value of every weight.
Yes.
So you just have a teacher signal that knows the state of the whole network. It knows the wrong answer and the right answer. We don't know the wrong and the right answer. We maybe after 10 minutes we find out like, oh, we hurt ourselves, but we don't. Not every millisecond we get like, oh, they were good, this was bad, this was good, this was 98% good, or this was at the so you're kind of cheating.
Yes.
With networks like ChatGPT and optimizing it, especially mostly for the GPU, and that's why you can kind of get higher performance. But it's not a good. It's not for computational neuroscience. We would say like, yeah, it is kind of cool that we have these big neural networks, but they're not models of the brain.
Yeah, so it's kind of like we ain't seen nothing yet. That's what it sounds like.
Yeah, it's kind of like, okay, we looked at birds and we built a jet fighter.
Yes.
But we don't know how wings work. We don't know how feathers work. We don't know how the flapping mechanism works. And then like someone else like, I built a propeller. And it flies. It's kind of based also on like air and... But so the neural networks you see now are mostly just kind of jet engines, and in computational neuroscience you really try to recreate a bird basically with feathers and find out how birds can fly and not how fast we can fly if we just can use anything we want, GPU clusters and like a $16 million training budget and train it on the whole internet. I don't think any kid is trained on the whole internet.
Yes,
it's just
of course.
So
actually, that's a very good metaphor. That the birds versus planes is a very good metaphor. This is awesome. So for the people who are like in neuroscience and psychology, if you're listening right now, you're hearing firsthand the utility of neuroscience to AI and machine learning. All right. Now, with that said, I might have some more questions about your academic program later. For now, let's move on to Kexu and your business. So you started Kexu in 2020. So how did you discover that opportunity, like that business opportunity?
Yeah. So actually, I always had the company Kexu. From I always had it, but I just. It was just kind of a side project, and then slowly it got bigger and bigger, and now we have, now we have 4 employees, 3 full-time, 1 part-time, and a couple of freelance people. So now it's really starting to take off, and but it's kind of like I always did it as a hobby, and then. When I kind of seriously full-time did my company, I just still had the same name, and then we just kept going with it.
So you mean that was Kexu always the eye tracking business, or was it something else and then you pivoted to the eye tracking?
Yeah, it was just the name of the company.
I see.
It was just it was. It was also kind of a random. It was a random name at first.
Yes.
So how I made the name is like my sister's boyfriend. He had the company Adyen, and it's one of the biggest payments providers in the world now. But at that time, it was kind of a small company. There were 60 employees.
Yes.
And he was talking about how he got the name Adyen, and they said like, yeah, I have different explanations for it, but a lot of times I just say like it's the only .com domain name with 5 letters that was left.
I see.
So I thought like, I also need a name for a company. That's kind of a fun idea. So like the day after, I made a Python script that could generate 5-letter words.
Yes.
It had consonants and vowels, and then just things that are kind of could be words. Yes. And then I checked if it had a .com name available, and I checked if it had 0 Google search results, because I didn't want to spend money on ads. Just like for a lot of companies, they have to buy AdWords for their own brand name, because they have such a common name. And I thought like, okay, I just want something that has 0 search results. So I think Kexu is a word that means nothing there's no language that has the word Kexu, because there were zero Google hits on a 5-letter word with a .com domain available. So that's that's kind of the story how we got that name.
I see. So that's a unique name to come up with. So let's talk about what Kexu is doing now. So what is Kexu mainly focused on now?
So now we build AI, mostly computer vision for companies. But we also have our own product, and that's really the thing we're working on most. And this is eye tracker. So here, this is deaf version. You can see there's a little bit of paper here because the camera is a little bit too low. So that and there's like a unprotected cable here. But this is the eye tracker. Oh, maybe I also have the beta version here. So this is the prototype, 3D printed prototype for V1. It's gonna be released in, well, I would say 1 month, but that's really optimistic. Like it's about 1 month, but probably it's gonna be delayed a little bit.
I hear you.
And before we had, like, here's still the beta version. So this is an older version that you can still see all the cameras, and this is kind of an off-the-shelf camera, and now we have a custom-made camera.
Quite the evolution.
So slowly, So for a while we had, and this works. It has the same software, so it does work. But now we made one that you don't see the electronics anymore. Yeah. And it's made in a way that we can injection mold it, so then we now have an order for 100 of these plastic glasses, and we have 100 of these cameras, AI tracking cameras, under 20 frames per second. And these are still off-the-shelf cameras, but
really cool.
So slowly, it's really nice to start with a prototype and then work more and more and progress kind of to first we had a proof of concept, then we had a beta version, and then we got some funding for it, and then now we're developing the V1 version. And so for the next 2 months, I'm really like, if after 2 months we have the V1 version like in a box and injection molded and with custom electronics that we built and with software working, and you can just order it on the website and it will work and it will connect. That's kind of the goal for this first part of the year. And then if at the end of the year we would have sold 100 of the V1 eye tracking glasses, then I would consider it a successful launch of the first eye tracker.
I see.
I think after that it will be easier, because like for this eye tracker I had to do so much, so everything was new. We got an industrial designer. We got custom electronics. I never did that before. I never did plastic design things. Now we have 2 industrial designers. So if we would create another version of the eye tracking glasses, we can just say like, okay, we want this now. But we also had to find software developers that were capable. Building a software and an app, I already did that before, so that is relatively easy for me. But getting an office, hiring people, contracts, giving people stock options, and everything there's so many new things that you have to learn when you start a company.
Yes.
It's not only the product development. Yeah, and also like with product development, there's from a proof concept to a beta, that's already a huge step. And then from a beta, then you think like the beta version is almost finished, but actually to go from a beta version to a V1, that's super difficult. There's just so many details that you need to get right. And then I think we're gonna have so this year we want to release the V1, and then I think we're gonna have whole other problems also with logistics and like if we sell 100 a month, that's going to be a total new skill to learn and to hire people for and to implement and to get kind of systems going and get marketing channels. And so, yeah, it's really, you really have to learn a lot of new skills to create a hardware product.
Yes, of course. This sounds pretty cool. And then when it came to the funding, what did that look like? So did you self-fund it to start and then you got funding after that?
We kind of built a prototype version of the eye tracker.
Yes.
And then I showed it to a company that wanted to get into eye tracking.
Yes.
And then they said, like, okay, you already got really far with this. And we want to add eye tracking to our product lineup. And then they said, like, yeah, we can, we could just pay you for the eye trackers. But actually what you probably need as a company is just some money now, before it's finished, to develop it further. So basically they said, like, here's some money and finish it. And then once it's finished, we will add it to our product lineup, and then we will start to make money from it.
I see.
So that's yeah, they guessed that they trusted that we could build it.
Yes.
And yeah, I'm very confident also that we did build it. That now, yeah, it is all the difficult stuff is finished now. So we got custom electronics that works. We've got AI that's accurate enough. We got post-process software. You can do a whole experiment, and yeah, it works. It connects. Everything works. So I'm very confident that we can deliver on that investment. So yeah, I'm happy with that. But now, it's still a step to really get it into the stores. And like I said, there's so many details. Like, for instance, one thing we had is we updated the login screen, and this is really stupid mistake, but yeah, we're 3 developers, and sometimes we don't know who is doing what. And then we updated the login screen to make it a little bit more efficient. And then people were complaining that they couldn't use the website, and they were sending pictures. And after a while, we realized that if you put the wrong password, it would just go to the next screen, but you wouldn't be logged in. So all the API calls would fail. So for 1 month, we didn't know that if you just put the wrong password, it would not give you an error message. It would just... But on our computers, we were always logged in. We had password managers, so it would always fill in the correct password. So we never even noticed ourselves. Yeah. So all those things, like to build. For instance, one of the hundreds of things that we built to make it more stable is that I think is really funny, and I think other companies should do this too, because it is really nice. Is that we have a chatbot that checks if all our servers are online, and then it posts in our Slack channel if the servers are online.
Yes. But
it posts a random GIF of success if they're online.
Yes.
Or of burning buildings and that kind of stuff when they're offline. So sometimes when we're deploying the server and it's like we take it down and we put it back up and then it's offline for 1 minute, then we get like 10 Slack messages with explosions and burning buildings and people screaming, "Oh no," and running away.
Well, it's good you have systems in place to even keep track of that so that you guys can get to it quickly. Oh, and keeping a time in mind.
That's super difficult.
Are you able to go a little bit past? It's about 4:50. Are you able to go a little bit past 5 p.m. your time?
Yeah, sure.
Okay, just want to make sure we're keeping well on your schedule.
Okay, yeah. No, this is my final thing for the day.
Okay, great. All right, and then since we've got some time, I'm a little bit curious about the Netherlands because I know because my grandmother's German, and then I took German through high school and also in college, so I know a lot about German culture and a little bit about other Germanic cultures where they're very actually risk averse. They're not very interested. They're often there's a cat in the background. You might hear the cat meowing. They're often not interested in like entrepreneurship or business. Sometimes they are, but they're often risk averse, so to speak. Is it somewhat similar in the Netherlands? But it sounds like you are meeting a lot of entrepreneurs just in your program alone.
Yeah, I think it's totally the opposite. I think there's so many businesses in Holland.
Mm.
And I think actually it's like you live in the US probably, right?
You live in the U.S.
And in the US you can companies can just fire you if they say like, okay, we don't need this many people, we fire some employees.
Yes.
And in Holland you cannot do that.
Mm-hmm.
And actually it's so strict with companies having to apply to so many rules that actually the hourly pay really goes down a lot, because like they're protecting the employees, but they are a little bit overprotecting them. And so a lot of employees actually just say like, well, I don't need all those protections. I just take my chance that I won't be in the hospital. I'm young, and if I am in the hospital, I'm just gonna sell my house. But what are the chances that that will ever happen? Or my wife also works, or in the worst case, she can. And then they just become self-employed, and they are just they become a freelancer. So in the Netherlands, a lot of people are freelancers. So really, really a lot.
Here's one more question. So so if you're a freelancer, well, I don't know. Americans always make fun of their own healthcare system. Like when you're a freelancer in the U.S. or you're self-employed, one reason so many people have regular jobs is because the jobs imply health insurance. But it sounds like you guys have like some sort of universal healthcare, where even if you are self-employed or a freelancer, you have.
Yeah, it's the same. The only thing is when you're not capable to work anymore, then the company has to pay for 3 years or something. They have to pay that you still get 70% of your salary or something. I don't know exactly the numbers, but the company is kind of, if they hire you, they're responsible. If you get sick and you can't work anymore, then for 2 years or something, they will have to pay your 70% of your salary or something, something like that. And when you become a freelancer, you don't have that. So if you become sick, well, the hospital bill is paid, but if you cannot work for 1 year, then you just don't have income for 1 year. So that's the main problem. But now they make more laws that you are forced to get an insurance for that if you are a freelancer.
I see. That makes sense. I didn't want to stay too long on that. I was just curious from like an entrepreneurial standpoint, because that holds back a lot of entrepreneurs in the U.S. is they're afraid of losing their health insurance.
Yeah. No, you don't have that in Holland.
I see.
No.
And then
no, you do have to get your own insurance, but it's only an insurance if you are not able to work anymore. Mm-hmm. And many people say like, well, if I'm not able to work anymore, I'm also not gonna take trips to Bali and stuff like that. So then I'll be fine if I don't. So most people really think like that. So they have a savings account in case that happens. But
1 second, the cat.
I think like, well,
here's one of the cats. She keeps making noise in the background. She wants to play. I'm listening.
Nice. Yeah, so healthcare is, it's I would say it's way cheaper in Holland, but it's more like, but it is really expensive. Like I think like 1/3 of all tax money goes to healthcare.
Yes.
But they're just forcing everyone to make the sensible and the like. People who are richer pay more, and people who are boredom pay so much.
Of course.
So
Yeah, I was just curious about that. So now moving on to, I don't want to have you drone on about healthcare because that's not the main topic here. So
yeah, but it's more
on
about entrepreneur.
yeah.
Yeah, so I think like I think in Holland actually they have two systems, and it's a little bit the socialist system and a little bit the U.S. system.
Yes.
And in the more socialist system, the employee is protected by the law really a lot. So that's also why here people are really afraid to hire people, because you're not allowed to fire them. If they get sick, you have to pay them,
Yeah.
and so it's more risky to hire people in Holland.
Yes.
But on the other hand, it's so protected. They're just gonna calculate the cost back into paying the employees less, basically. So a lot of people just think like, okay, I don't need protection. I'm just gonna be self-employed, and then you get way higher pay,
Yes.
about really twice as much, and then it's more kind of on par with. Then it basically becomes almost the same as a system in the US.
I see. That makes some sense. Now, I was just curious for that because I think some people might be interested in the systems that allow and support entrepreneurship. That's why I was interested in that. Now, on the topic of, let's move on to AI and machine learning a little bit more. We talked about some of what you're doing. Let's talk about the future, like what you're seeing when it comes to the future of AI and ML, and how neuroscience might play along with that or influence that.
Yeah, I have a hope.
Yes.
Kind of like, I don't know if this is gonna work this way, but it would be cool if for instance, in neuroscience, if you build neural networks, the neurons are only allowed to know their own state, and in the brain, not every neuron knows the other state of all the other neurons.
Yes.
So it has to have a learning algorithm that only relies on the local state of the neuron.
Yes.
And in AI, you have more like you need some kind of global state system. So it's also the global state is probably way more efficient, but it will probably also reach a kind of tipping point where it's more efficient to have only local knowledge, because you can scale further. You can scale with more different machines. You can machines don't have to have a super fast connection between them. They don't need to necessarily be linked. They can just once in a while update their state. So I think after a certain scale, and also our brain is obviously a way bigger scale than even the biggest artificial neural networks. Then after a certain scale, you will have to kind of get more locally focused learning algorithms. So maybe, but I don't know, maybe they'll just solve it, or maybe they'll just connect it with super intense data links, and they will, or maybe just find some kind of halfway solution. But it could be that after a while, the network will become too big, and then it's then if you build it more like the brain, it can be more modular, and it can have fewer connections between different parts actually of the network. So then, in theory, that would maybe allow you to build a way bigger network that would ever be possible with current machine learning algorithms. So I think like after a while, you're gonna hit like a spot where you can't really make them any bigger anymore. And then if you would make them like 10 times bigger, so if you would build the same network with only local learning rules, it would perform worse. Because it's obviously kind of cheating that you know all the information everywhere. But after a while, you're gonna hit a kind of a wall, and you can't scale it anymore. And then with only local information, you can scale it like maybe 10 times bigger. And then, even though it is less efficient way to teach neural network, it's gonna be better overall because it's just 10 times bigger.
Yes.
So that's maybe something that computational neuroscience, because you have to build local learning rules because that's how the brain works. And then maybe someday that will be taken from computational neuroscience into actual neural network to get that tenfold skill increase and to get behind that kind of barrier of a certain maximum skill of artificial neural networks.
I see. Now, there are a lot of people who are in my audience that are either neuroscience students or psychology students, either in undergraduate or grad school, or some of them are psychiatrists. So for the people who might be in school and the younger folks, do you have any advice for them, like when it comes to, like if they're interested in neurotech or AI and ML or things like what you do? Do you have any recommendations for them, like what maybe they should study in school or what they should do on the side if they want to work in neurotech or something like that?
Yeah. So the real difference. I'm doing neural networks for a really long time.
Yeah.
So what I always build my own neural networks, and right now what you see is everyone just downloads Torch or TensorFlow, and then builds new things with Torch or TensorFlow. Mm-hmm. But that's really out of the 500 ways to build a neural network. Torch and TensorFlow are made for one type of neural network, and that's kind of the one that won the race. But if you really wanna investigate new, if you wanna discover anything new, you're not gonna discover it by creating another network in Torch, because you kind of just do the same thing, but it's very slightly different. So I think it's also valuable to not only just copy a GitHub repository with another Torch network or create another Torch network, but with 6 layers instead of 4, or maybe because you're just gonna kind of because you're in the kind of if you just gonna
It'd be hard to make
that kind of
maybe.
building blocks, you're just gonna build the same things all the time, and you won't discover really anything kind of really innovative. So I think so. So it is nice also just to try to build your own neural networks. And before you really needed the GPU accelerated and CUDA cores and stuff like that. But right now, if you run the neural networks that kind of started the deep learning revolution, right now CPUs are so fast, and you could even if you would run the same network on a CPU now on a decent computer, it would still probably be faster than when they build it on the GPU then. So it's not that necessary also anymore to get it that performant if you just want to build a network just to try out a new learning rule, or just try out a new maybe evolutionary algorithms. There's a lot of evolutionary algorithms that are also ways to train networks. There's a lot of different ways to build neural networks, and actually now 99.99% is just one way to do it. So there's also a lot of other things to explore.
Yeah, of course, that makes sense. I feel like I'm seeing something similar when it comes to all these platforms that now they create text copy or they create images. They're all either using GPT or they're using DALL-E. I mean, they're using GPT-3 or DALL-E or OpenAI's image system, but they're all using the same system, so it can be hard to then differentiate because they're all using the same foundation.
And GPT is also using the same thing, but then just way bigger or more expensive hardware. So it's also just like the same, exactly the same, but then way bigger. And then they did find some more tricks to train these really huge networks.
Yeah. You were speaking about pretty advanced things. My question was more so for the people who aren't even there yet. For the people who who are just like who just they either like neuroscience or psychology, or they're in their undergrad. What might be some like recommendations for them about what they should consider for the future?
What they could to do or to learn.
Yeah, like if they want to have a successful career, let's say it's in neurotech, what might they want to
career?
Consider? Yes,
I think for any career now, you need to be good at programming.
Yes.
So any field you work in now, you would become better at it if you learn Python, for instance. It's
Yeah.
really easy to learn. Python is not so difficult as like C++ or something. Anyone can learn Python, but if you learn Python, you're just gonna be able to do way more in any field. If you do economics and you learn Python, you're gonna be way better at it. If you do psychology, you learn Python, you're gonna be way better at it. If you almost anything now, you can benefit from being able to build some kind of simple scripts, and so I would recommend, even if you are really in humanitarian sciences, to also kind of take a side course of Python, just to be able to. It's so powerful. You can just you can do so much more, and really any field can benefit from knowing a little bit of computer programming.
I see. So that's Jurriaan's recommendation. Learn code, learn how to do Python, because it's going to make you stronger. It's what it sounds like. Makes you stronger. It can make you more effective. Correct?
Yeah.
All right. Now let's move on to the fast four. So these are just 4 quick questions I want to ask to kind of understand more about you. And I think there are 4 questions that a lot of people might be curious about with all of my guests, and especially you. So first one, it sounds like you're doing a lot, but how many hours of sleep do you get per night?
I really like sleeping. I really love sleeping. So I actually sleep kind of a lot. I sleep a lot. I sleep like 10 hours a day. I really like sleeping.
So is that like the average is going to be around 10 hours per night?
Yeah.
Really?
I think so.
That's impressive.
I am also like, it's really funny because when we did school assignments in the university, then I would always take way more breaks than anyone else, and I would always finish way faster.
Yes.
So I think like you're gonna be faster if you take more breaks.
Of course. I see. Yeah, because being well rested. Most people don't sleep enough, or they think, oh, I got 4 hours of sleep and I feel fine, but then they're not fine when they're actually working because they're half asleep, or they can't focus because they're not.
They think they're gonna get more hours in the day if they sleep less, but those hours will be so much less effective. So I think like for me it's really important to kind of say is like rest, social, do social things, and sports. I think those things, if you have to spend some hours on that, and then you're just gonna be faster in the hours that you, and more focused.
Okay, so I wasn't going to ask that. That leads to this next question. Well, go on. What were you going to say? Go on.
Yeah. So I think like to sleep less and get more hours in the day. I think like I think you can only focus for maybe 4 or 6 hours a day.
Yes.
And if you can focus for 4 hours or focus for 6 hours, I think it's depending on if you do a lot of sports, if you do have a lot of social things, if you get enough sleep. So that will really say like, oh, you can focus 4 hours or 6 hours. So if you live really healthily, then you can focus for 6 hours. If you don't sleep enough, you can focus for 4 hours.
I see. See, this is really cool. I was not expecting you to say 7. So that leads to my next question, which I wasn't going to ask, but how often do you exercise? Because it does look like you're in good shape. So do you make a lot of time for exercise and fitness?
Yeah, I play tennis and I go to the gym, but not really extreme. Just I do try to not eat sugar. So I always have like this. I think it's the greatest invention: 0 sugar. I think like can have the best of both worlds, and we can have that nice taste of sugar, and we cannot like be trapped like the moth in the environment that suddenly has a light bulb somewhere.
Interesting.
So I think that's a really good invention.
You say 10 hours. So you do 10 hours of sleep, and you still have time to. You make some time to do some exercise because obviously you're I don't know if it's just most Americans are fat, so I mean maybe you're probably like the average healthiness for.
Yeah, but that's because like I've been to the United States, and that's just if you go to there's just no healthy food there.
Yeah.
So that's the problem. The food it's and also the kind of the attitude towards how important healthy food is. So I think like here to eat things with sugar for breakfast is really like, then you're really like messing yourself up.
Oh yeah, it's such a common thing in America. I don't want to.
Yeah, the whole image there is like, yeah, that's kind of normal. Everyone does it.
Yeah, people eat like cereal, sugary cereal, or pancakes, or strudels for breakfast here.
Yeah. If I'm in the US, I also do that. I think it's like super nice. But in Holland, if you would do that, everyone will will look at you like, what are you doing? That's so unhealthy. It's not that they think like, oh, you're gonna be fat, but it's like, no, that's super unhealthy.
Yeah, of course.
And also, if I had friends from the United States here, if I would eat dinner at them, they didn't have vegetables with their dinner. And for Dutch people, it's really to eat dinner without vegetables is really like, if you do that for a week, you're gonna die. Basically, that's what they think here. Like if you wouldn't eat vegetables for 1 month, they will think like, oh, then you're gonna probably be in the hospital. And in the United States, I don't think it's like either you're a health freak and you eat only vegetables, or you don't care about it. So it's like I think it's just a whole and all the supermarkets are like that. So it's only vegetables and fruit everywhere, and almost no sugar and salt. And then I was in the US and I tried to tried to find something that was not fat, sugar, or salty. And I was looking for 2 hours, and then I gave up, and I just got a donut or something.
Right.
But
you're
it's just
stay healthy, stay wealthy.
Yeah, but I don't think you need to be super healthy for.
Well, you are compared to most.
I think it's just the environment. Like also for if I have chocolate in my room, then I will eat it. At a certain point, I will be hungry, and I will be too lazy to go to the store, and I will eat chocolate. Yeah. And then I'll become fat. So what I do is like I never keep chocolate in the house, but I put fruit everywhere. So then when I'm hungry, I'm too lazy to go to the store. I have to eat that fruit. And I think like on a way bigger scale, it's kind of the same in Holland. But I think like Holland is one of the weird countries that are super skinny. So I think like all the countries around us are really fat, and everyone's getting fatter. But I think there's a whole everyone is really all the parents always say like, no, you have to eat at least one fruit a day, and you have to eat vegetables, and no, you can have like one Coca-Cola each week, and that is like a special occasion, and it's just a whole everyone is taught like that. So I think this
is why the Dutch are so healthy and also so tall. You guys have the highest average height of any country. So now I'm seeing why. Okay.
Yeah, so only in the 70s or something, the people in the US were taller than in Holland.
Yes. All right, and then the next question I have is let's move on to this one. Sometimes people often like to ask, "What's your favorite book?" But a lot of people don't have one favorite book. So let's say your one or two favorite books that you like a lot that were very influential. If there's
one of the books that I always recommend to everyone, because there's a lot of like the 10,000 hour rules and all the same books. But one of the books I really recommend to everyone is The Undercover Economist.
Undercover Economist.
And almost no one knows about it, but it's super interesting. And it explains all kind of very... it explains economy that it's nice for a consumer. For instance, it explains why you always have different prices of certain, and why why, for instance, some things are this price and that price, and yeah, it's super interesting. Then you will start to look at the world really totally different, and it's also super funny to read. It's very written really nice.
I see. So undercover economist.
Yeah.
All right, and then next question: what are just give me a maximum of 3. If you have just one, that's fine. But let's say a maximum of 3 habits you would attribute to your success.
Never giving up. I think that's. I think it's really a problem for me sometimes, but it's also a good thing.
I don't believe you, but go on.
And yes, and yeah, I want something that contributes to my success is also, yeah, I am to brag a little bit. I am pretty smart. I'm really a little bit. I'm kind of creative and smart in a creative way. So there's a lot of things that no one else could build, almost no one else could build, and I can build them.
Yes.
So yeah, that gives me an advantage.
Yeah, but I would say that some people, they blunt or they mitigate their effectiveness and their intelligence because they either don't sleep enough or they eat junk food or they don't exercise. So then they wouldn't be able to act as smart as they otherwise would be. Like, there are a lot of people who are smart, but they sleep 4 hours per night. So
yeah,
they're dumb.
And yeah.
I see. So
you gotta
maybe, but also use the intelligence well and maintain it.
Yeah.
I see. So we've got
maybe, but yeah, I think also if I would just be very unhealthy, I would still just be like I'm also bad at a lot of things, but that's one thing I'm good at. And I don't think all successful entrepreneurs are smart.
Yes.
Like some people are maybe like really good at reading people, for instance. I'm not really that good in that, but like in building technology and kind of getting creative mathematical solutions to problems that I'm really like if you show me, you can make a neural network that can solve the Queen's problem, and the next week I have built one that can solve a Sudoku puzzle. There's just like not so many people can do that. Maybe 1% of the people could do that. So I think that gives me an advantage. That's one of the.
I see. So you've got some natural intelligence and also never giving up.
But I think, and the third thing that is that I am really engineer, like a computer nerd.
Yes.
But I also really like a lot of my friends are sales guys, and I'm also kind of a weird combination between both worlds.
Yes.
So at a certain point, I thought, okay, I like startups. I want to work at a startup, so I'm just going to find a job at a startup. And then I looked through all the startups, and they either had only engineers or only salespeople.
Mm-hmm.
And I think the problem is that salespeople, they cannot talk to engineers, and engineers, they cannot. They don't like each other usually, and they're totally different type of people. And so you have a lot of companies that have either only engineers or only salespeople. That's at least that's what I found when I was looking for a nice startup to join. And with me, I really like both. I'm like super interested in mathematics and in computational neuroscience and that kind of stuff. And but a lot of my friends are salespeople, is bragging about money and that kind of stuff. And I think like a lot of people who are interested in mathematics, they really don't like that those kind of people. So I think that's that also. If you want to start a startup, you really have to do everything. So in a bigger company, you can really specialize a lot in one really specific thing. So, for instance, you can do only recruitment or something, or you can do only DevOps. But in a startup, if you start from the beginning, you really have to do everything. So then you have to really be comfortable in all kind of different environments. Talking about servers, talking about computer programming languages, but also doing recruitment, also talking to salespeople, customers, and also doing the accountancy and also think about stock options, that kind of stuff. So a lot of different things. So you have to be really all round.
Mm-hmm. So you would say maybe one habit that you have that maybe others want to consider is considering the other sides of skills, like considering both the hard skills, like the engineering and development, but also being considerate of the softer, quote unquote, skills like communication, marketing, and sales. Is that what you mean?
Yeah. I don't know if I'm necessarily good at communication, if that's really my skill, but I do like people who are good at it.
Yes.
I think that's the main difference. So I don't necessarily have to do it myself, but I do hang out with those people, and I do like if they're at. I do like to collaborate with them. And
So it sounds like it's important to recognize the importance of those skills and not be ignorant of those skills, basically.
Yeah, and get kind of a group of people together with all kind of diverse skills, and not just a group of only engineers or a group of only salespeople. Because it's just so much stronger team to have one engineer and one salesperson than to have two engineers or two sales people. Just those, if you want to build the strongest team, you wouldn't say like, okay, we're gonna build a team, we're gonna have 20 engineers, or we're gonna have 20 lawyers. Now you would say like, okay, we can have 20 people. Okay, we're gonna have a couple of engineers and maybe one or two people who are better at design, and then we're gonna have some salespeople, and then maybe we're gonna have a lawyer just in case, like to get all the contracts really perfect, and then we're gonna have this kind of person, that kind of person. So a lot of people really only like one type of person, and they're not open-minded to anyone that thinks differently than them. So they just form groups with only engineers, or they form groups with only salespeople or only designers. And I think if you want to start I think in a bigger company, that's fine, that's perfect. But in a small company, when you're just like 6 people, then you really have to have all kind of different talents in the same group.
I see. So it sounds like assemble a team of diverse skill sets.
Yeah. Yeah.
Makes sense. All right, now to wrap up, if we want to find you or connect with you, where should we go?
I'm on LinkedIn.
Mm-hmm.
Jurriaan Schreuder. I don't know if I can put the name. It's a really unique name.
Yep, it's K. Can you spell that for us?
KEXXU.com.
All right, it's kexu.com, and then I'll put a link to Jurriaan's LinkedIn into the show notes, and also a link to Kexu in the show notes. And if you want to connect with him on LinkedIn. So, Jurriaan, this was awesome. Thanks for joining me and sharing so much. You shared a lot of information. Thanks for giving us some extra time. I really appreciate that. So, thank you.
Yeah, it was really fun. Really nice. So thank you for inviting me. And see you around maybe in the next podcast. Maybe in a year we'll do a follow-up and see how far we came in the meantime.
All right, it's been my pleasure. Thank you. Sounds good.